Hello everyone, my name is Dean and welcome back to another Java tutorial. It still sounds wrong to say, but here we are. I'm just going to run through real quick what we're covering today and then we can jump into the code. So we're going to start off by covering the primitive data types in Java. So this is going to be your integers, your characters, or your Booleans, your conditions. So like true or false. Can your character use the skill at level 21? If it's true, then yes, they can use it. If it's false, then no, they can't. We'll also cover the, some of the bigger data types. So let's say you need some really big numbers. We'll cover those. We'll cover how to get the biggest value a number can be, or the smallest value. We'll use some smaller third-party libraries. So we're going to be using the math library in this. This is just to sort of get you comfortable with using some of the tools that Java gives you to make your life easier so you're not constantly looking stuff up. Then after we cover that, I believe the next thing I cover is the basic operations. So your PEMDAS, your order of operations. So parentheses, exponents, multiplication, division, addition, subtraction. We'll sort of cover how to do each of those to some extent. Then we'll finally cap it out with how you get the absolute value of a number. So we'll do that with the math library. And we'll cover how to do the power of a number. So 2 to the power n. So like, let's say 2 to the power 3 is 8. So we'll cover all that. I'll show you where to go to learn more about this, like where you go if you're coding on your own and you're like, oh, I need to use a math function. I don't remember what it's called. There's actually documentation for you that you can use for that. So I'll cover all that. Hopefully things will go smoothly and you'll learn a lot, but that's going to do it for me. Let's go ahead. Let's jump into some code. Okay, so we're going to start off by talking about some of the primitive data types, and then we'll cover some of these pages once we get to the point in the tutorial where we need them. We're going to start off with one we covered in the last episode, which is your integer number, and we'll just call this, I guess, my number. And I'll say this is equal to 42. This is your standard number that you'll most likely be using most of the time. This is just your, I need a whole number to store this thing type of data type. So no decimals here. The biggest this number can be is like 2 billion, which is 2 to the power 32 minus 1. And the smallest it can be is -2 to the 31, I believe, or 32. I think it's over here on this page. Let's see, int. The minimum value is -2 to the 31, and the maximum value is 2 to the 31 minus 1. So why is this one -1 when this one doesn't have that? Well, the reason is your maximum value is what happens when you go to the max positive, of course. And when you start to go into the negatives, one of your 32 bits needs to keep track of this negative symbol right here. So you can sort of think of this as being the counterpart to the negative symbol, because a bit can either be a 0 or a 1. You have two choices. One of the choices would be an actual value. The other one would be the negative symbol. So we do have to offset this by 1. Now, if you go above the 2 to the 31 minus 1 value, and let's say you add 1 to that, you'll end up with a negative number. It'll be your absolute minimum. And if you're at your absolute minimum and you subtract 1, you can go to your absolute maximum value. So they sort of loop around, which means that's something you do need to watch out for and make sure you're not adding two really big numbers together. Now, if you do have big numbers like that, the long type, it can also be very helpful. So we'll just call this bigger number. Say this is equal to, 3,000. Now this can be up to -2 to the 63 in size, or 2 to the 63 minus 1 for the same reason. It's a signed data type, so one of your bits is used for the sign. And this is a really big number. Like, this is borderline incomprehensibly large. I don't even know how I would picture a number this big. That said, sometimes you do need bigger numbers, and that's where something called a double comes in. So you have a double, which is a really, really big number, right? And this is, you could just set this to whatever, it doesn't matter. One thing to keep in mind, though, as these numbers are used, you might be adding one to the other. So let's say you have your integer and your long. And let's say you say, we have like another int. So we'll say int new number equals my number plus bigger number. And this is going to throw an error. And if we hover over this, it says incompatible types, possible lossy conversion from long to int. And all that's saying is that because this number is bigger than this number, by trying to store this inside of an int, which is a smaller data size, this number could be bigger than 2 billion, which could cause this to not work properly. So ideally what they would have you do is have you make both of these a long, make this a long, or I guess you could even leave this as an integer. And that's just because this number should be able to handle it. Now, of course, this could also completely go kaputs on you, because if this is your maximum float value and this is 1, then this is also going to not work, right? So that is something to keep in mind. Now, the other thing to keep in mind is that integers work just as you would normally expect them to in math, but some of these other types, like the long type, sometimes requires you to put an L at the end of it to indicate it's a long. This one requires you to have a D at the end of it to indicate it's a double. And that's just so that if you're adding this number and this number together, for example, it knows whether you want, like what kind of, or I guess not really for this one and this one, but if you're adding this one and this one, so it knows that this one's supposed to be a long and this one's an integer. This is very rarely used, but it is something to keep in mind. Most of the time, most of your math, unless you're doing something very math heavy, it's going to just be using integers or longs. And even when you're using longs, you usually won't find yourself doing this all that much, at least anecdotally from my experience. So the last type to talk about is this double here can actually take decimal places, and so can a float. So we'll say this is my float. We'll say this is equal to 3.14 because we like the number pi. And you can see with this float, it's immediately throwing a fit. And that's because it thinks that the value here by default, because it's a decimal, is a double. So in this case, with the float, you do have to explicitly say F. And you'll do this almost every time you use a float. You'll just get used to throwing an F at the end of it and just pretending like that's the way things, that's just the way things need to be. So now that we sort of have these numbers out of the way, we can quickly go over some other types. One of them is going to be a, let's see, I don't know if it's Boolean in Java. I'm getting my languages confused. And a Boolean is just, I don't know, do I like pizza true? A Boolean is just a true or false. So this is 1 bit in size, and it's just, a 0 if it's false and a 1 if it's true, I think. By default, it depends on the language, but I think that's how it works in Java. So this you'll just use whenever you want to store a condition, like, does character have skill unlocked equals true, then they can use the skill. If it doesn't equal true, then they can't use the skill, for example. You also have a short. And this is just maybe you're working in a very memory intensive environment. And let me actually move this above the integer, and I'll try to order these in terms of the size of the value. So if you're in like a pretty constrained environment, but you still need to use a number that's, anywhere from 1,000 to 32,000, you can use a short. So this is, I don't know, a smaller number. Say this is equal to 7,056. And this is just your, sort of your conservative small number that you're going to use, but you still need to be able to store a decent amount of stuff. Now, for those of you that have used or played Minecraft before, you might be familiar that at one point, I don't know if they still do, but at one point, they actually stored all of their blocks in a byte array. And this is no different. So this number can be between, I believe it's -128 and 127. Same thing right here. Looks like that's true. And this is just an actual byte. So you can actually model this one out if you wanted to, if you know your binary. So because it's a byte, it's going to look something like this. And then we can just model out a few of these. So let's say you have the number, I don't know. Let's say you have the number 1, or you can do the number 2. Or you can do the number 3, or you can do the number 4. And you can sort of see how this continues. And basically covers all, 256 different numbers, right? So this is for your power 2 to the power 0, I believe, 2 to the power 1, or I guess 2 to the power, 2 to the power 2 minus 1, I guess is what it would be. And this would be 2 to the power 1 minus 1. And this goes all the way up to 2 to the power 8 minus 1, which should get you close to that number. It doesn't matter. But the basic idea is it's just a small byte that you can use to store your values. So if you have a smaller value that you need to store, byte's pretty standard to use for that. But again, it's all going to depend on if you're working in a very memory intensive environment. In a lot of cases, people just use an int because the memory difference at this point with how big our computers are, most people just really don't care. And then the last one, I believe, if I haven't missed any, is just going to be a char. So we'll say my initial, and this is just equal to the letter D. Now this one does go inside of single quotes, and this is just a single character. So you can sort of think of a char as how strings are built. So in the last episode, we had string, what did we say? String initial plug, right? And this was just equal to some words here. Well, you can sort of think of this as like, this plus this plus this plus this, or something like that. And that's sort of how it's building the string. Now, of course, that's not exactly how it works, but you sort of get the idea. So we'll just say hello world. So that's sort of all of our types here. And again, I'll have a link for this page in the video description. It does also cover some additional stuff, like what the default values are for each one. So if you create a new one, you can expect the byte to be 0, the short to be 0, the long to be 0L, the float to be 0.0F, and Boolean to default to false. But what can we do with this? So the next thing we can cover is sort of your operation. So you've already seen me do plus. You can probably reasonably assume what minus is going to look like. So I'll say int result equals 10 minus 4, I guess. And then let's just do a system.out.println, and we'll just print result. And let's actually do one more of these above it. So we'll just also print this one to the command line, and we'll just say my result was, and we'll get rid of the print line, and we'll just leave the space here so we get it a bit neater formatted. We can run this and we can see what this says. So my result of 10 minus 4 was this, right? Okay, so let's actually do something else. So we'll say int a equals 0, int b equals 0. And then instead of saying my result was, I can just say whatever this operation is right here. So in this case, we had 10 minus 4, but let's say a is equal to 10 and b is equal to 4. And then grab a, grab b, and then we can actually just grab this whole thing, paste it in here, and then let's put a equals symbol after it with a space. And then when we run this, you can see we sort of have our expression right here being printed out. So int result equals a minus b, which equals 6. Of course, this you'll have to copy and paste this every time, but if you're debugging and you want to see what this is doing, this is a good way to see it. For now, I'll just say result is equal to whatever. We'll just do this. Okay, so we have plus, we have minus. We can, of course, also do, let's say int c equals 32, and then don't forget your semicolon. And then after a minus b, we can then say plus c. We can run this, and it'll just do these in the order of operations, which is a good thing to make a note of. Math operations follow PEMDAS. So if you don't know what PEMDAS is, I can quickly write that out for you. So parentheses, exponents, multiplication, division, addition, subtraction. So this is the order that PEMDAS happens in. I'll just paste this up here so we don't have as many comments. And one final note, if two things are the same level in PEMDAS, operations happen left to right. So let's say you have A times B times C. It's not going to do all of this at once. It's not going to do B times C first. It's going to do A times B times C. So if we run this, we can figure out whatever this is, because this is how you do your multiplication. Don't put X's here, because X's could be a variable. So in general, they don't let you do X for your multiplication. It does have to be the asterisk. You can see here the result of that was 1280. Okay, so that takes care of multiplication, addition, subtraction. Maybe you want to do a bit more complex math here. So maybe you want to say this should happen, A times B. And then after that happens, we want to subtract C. So you want it to happen specifically in this order. You can put your parentheses around it, and this will work just like in math. Just make sure you're actually using parentheses. If you try to, let's say, use square brackets here, it's going to yell at you. It's going to say illegal start of an expression, and then it's not going to understand how to fix it. So make sure you're using parentheses, not braces or brackets, and this should work exactly how you'd want it to. Now, of course, you can nest these, so you can do this and then say plus 42, and this would also work. But what happens if, let's say we get rid of this and we just do, let's do A plus B. And B is now a double. This is now going to be upset. Why is it upset? Again, this is a incompatible type because it's trying to convert from the bigger data type of double to the smaller data type of int. Because this is a bigger data type, this plus this could be a lot bigger than this, and things could break. If your result is a double, this is no longer an issue. But it's important to note that if this is 1 and this is the maximum value of a double, then this could break. And I can actually show that to you. So we'll take our int result, say A and B. We'll make A equal to 1. And then for B, what we can actually do, there's a class library that we can use. And for all of these, I believe I have the page open somewhere. Maybe I don't. Okay. Basically, for all of these types here, there is a capital first letter version of the type that you can use to get information about the class or about the type. So we'll take integer, for example. In this case, you have to spell out the word integer. Then you put a dot, just like when we do the system.out.print or system.out.println. The first word is a class or a class library. So that needs to have a capital letter. So in this case, it's capital letter I integer, dot, and then whatever you want out of it. So I'll put a dot here. You can see all of the stuff in here that you can use. Some of it won't necessarily make sense, but some of it's pretty straightforward. So if I give this, if I use max here with an int A and an int B, so I pass in one number here, comma, another number, it'll give me the max value of that number. So that's pretty cool. The one we're after, though, is our max value right here. So you can see here a constant holding the maximum value an int can have, 2 to the 31 minus 1. You can also see here, bytes is the number of bytes in an int, and it'll tell you there's 4 bytes in an int, which means there's 32 bits, because there's 8 bits in a byte. But for this, we'll grab the max value, because you don't need to know about bits and bytes right now. So we'll say this is the absolute biggest number that can go in an int, and this is 1. And we're going to take the biggest number that can go in an int, and we'll add 1 to it, and we'll see what that number is. What we can also do, actually, before we do this, let's just print out B. That way we can see what the biggest number we can possibly have is. So you can see here it's 2.147 billion, or 2,147,000,000. And if we undo this, or put the result in here, and we run this, this is going to be negative 2.147 billion. And the last number here is going to be a little bit different than the last time we ran this. But that's just because we had an overflow here. Now, of course, you can remedy this if you just do double of b, and instead of doing the integer max value, we just copy it up here. So we make this a bigger number, add the d to it so that this stops yelling at us, because without it, it knows this number is too big. If we actually move this down 1, it'll be fine. But because 8 makes it bigger than the integer max value, we then have to add the d. And then we can do double result a plus b. We can print this, and this will work just fine. So you can see here, it's actually returning scientific notation. That's fine though. The number still worked. What we could actually do, we could make a 10, or actually let's make a, 100,000. And then let's change this to a times b and see what number we get back. And it looks like that is e to the 40 or to the 14. So you can see this can handle really, really big numbers. And that's sort of why you need to be conscious of which data types you're using and for what. Okay, so now that we have all of that out of the way, let's talk about the elephant in the room, which is everyone's favorite topic in math when they're in grade school, at least as long as you're doing the long version of it. How do we do division? So if I say int result is equal to a divided by b, I'll make b another integer. And let's use numbers that we can understand. So I'll take 28 to be a, and b can be 7, which means that our result here, int expected result should be 4. So when we do a divided by b, we expect to get 4. And we're not going to use this expected results just so we can read it. So if we run this, you can see here the expected result is 4. What happens if we change this to an 8? Well, if I come over to Google and I type 28 divided by 8, I get 3.5. If I run a divided by b, which is 28.8, that means this should be 3.5, which means this needs to be a float. So change this to a float, give it the f. Now it's not complaining anymore. This isn't going to give us 3.5. This is going to give us 3. And the reason is it treats both of these as whole numbers, and it treats the result as a whole number. So when it does a whole number divided by a whole number, there's no decimals there, and the result has no decimals. What we could do, of course, is we could let's make this a float. So float result equals a divided by b, but this is still not going to work because both of these are integer values. So you're going to get 3.0 because your result is of type float, but both of these are of type integer. And the way you can fix this is by making either one of these a float. So if we make 28 a float and we run this again, I would expect to see 3.5. And we can also undo this and make b a float instead. And I would expect to see 3.5 as well. You can see there, that seems to work. What happens if this is an integer and we're using float math to divide? It's going to say, hey, you can't do that because you're going to lose some precision going from a float to an integer. So that's one thing to keep in mind, is just that you do need to use floats for both sides of this if you're going to be doing floating division. And this does also work with doubles, of course. And you can go from a float division to a double just fine. But of course, if you have a double here and this is a float, it's going to be upset because a double is a bigger type than a float, which means you can lose some data. So this is going to say incompatible types, lossy conversion from double to float. So that takes care of all of that. And now the final thing I'd like to cover, now that we have all of this out of the way, what happens if I want to do exponents? So there's two different ways you can do this. The first, if I just change this to an int and I leave this as a plus b, a plus b, and then I change all of these to an int again. I think I just went into insert mode. I get rid of this, and I get rid of this. And I get rid of this. There we go. Actually, I can just get rid of this whole line. So if I have A and B, I'll leave this as, let's say, the number 3 and the number 2, right? So if I want to do 3 to the power 2, the first thing I can try is just doing A times A. That gives me A squared because it's A times A, which is A to the power 2. Of course, you can see why this doesn't really scale well. What happens if I want A to the power 5? Well, then I have to do times A times A times A, which means that this B variable is basically useless. What we could also try doing, in some languages, you can do something like the star operator to do your multiplication. That's not supported in Java, at least as far as I know. So the only thing we can really try is to use a third-party library. And for this, I have a web page open. It's for the, this is again built into Java, just like with the system.out or with the integer type or the float type. So like, for example, you can do capital F float dot, and then get its max exponent, its min exponent, its size, its max value, and stuff like that. But with this one, it's called the math class. There will be a link in the description. And we can type capital M math, which is the name of the class library, of course, dot, and then you'll see all of these wonderful things you can use in it. And on this page that I'll have in the video description, it also has all of them just listed out. So you can see here, I can get the absolute value of a double or of a float or of an int. And all I have to do is just say math.abs, pass in a number, -6. And then if I run this, it'll give me the absolute value of -6, which is +6. And we got +6. The other thing we could try, if we're trying to do exponents, this is actually for a different operation. This is your e raised to a power operation, so don't use exp. But there's one in here for, let me see where it is. I think I went past it. POW for power. So we can say math.pow. We pass it our number that we're using as the base, and then we're passing the number that we're using as the exponent. Now you can see here that POW takes in a double, and it returns a double. And because this is going to give us back a double, and a double's bigger than an integer, this error is probably going to say no lossy conversion, which it does. So what we can do is we can change our result to a type of double, and then this will work just fine. And of course, this makes sense. Integers are going to, if you're raising them to powers, they can very quickly become very large numbers. So having this return or give back a double makes sense. And you do need your comma here. If you don't have your comma, it'll also complain. Let's see what this error is. It says it was expecting a parentheses, not a statement. Semicolon was expected. Either of those just means you need your comma there, because this takes in two different arguments. It takes in a double A and a double B. So you need two doubles here. Simple enough. So if I run this, 3 to the power 5, I don't really know what to expect, but it's probably going to be larger than, looks like it's 243. What other numbers could we try? Well, let's try 7 squared, which should give us 49. And it gives us 49. We could do 84 squared, which should give us 7,056. Or we could try, let's say 10 to the, I don't know, let's try 10 to the 100, see what happens. That's a pretty big number. It looks like it handled it just fine. It's 1.0 e to the 100, which makes sense in scientific notation. And then let's try to break this. I think the max value here is about 340, so let's make this 400. Let's see what happens. We run this, and our result is infinity, which of course isn't accurate, but doubles can't go bigger than infinity. So when you're playing those games where the idle games where your currency goes up into the bazillions or whatever number they use, those numbers are often a lot bigger than a double can hold. And in that case, you use, similar to this math library, you use something called a big number. And that's usually just some code that someone wrote that you use like a library, but it's not actually supplied by Java. So you can sort of see how having all of these tools here, you sort of start to build your own tools when the language doesn't give you the functionality that you need. So let's say you need like a really, really precise big number library. Normally what I do, I go to Google, Java big number library. I search for it. This right here, first link, big integer. It might even be supplied by Java. I don't know. It looks like it is supplied by it. Arbitrary precision. Today I learned. Huh. I guess that answers that question. So sometimes even people that have been programming for years, they just stumble across some of these things. It's just how the world works. You're always going to be looking stuff up. Don't be afraid to experiment like we did in this episode. Changing some of these numbers like a float just to see what happens. I think if I change it to a float, it's going to be mad because it's taking a double and it's giving that back to me. And the worst thing it's going to do is yell at you and say, you gave me the wrong data type, right? It's not like you're failing the class or you're failing to learn to program if you get the wrong result. Most of your learning comes from reading those strange errors and seeing what it's yelling at you for. So that is something to always be cognizant of, is that errors are your friend as long as you understand them and you can figure out how to solve them. Okay, so that's going to do it for this Java tutorial. Today's been a long day. I'm pretty sweaty. Hopefully you learned a lot, and it's not as hot where you are as it is here. But that's basically going to do it for me. Next time we'll cover some conditional branching. We'll cover how to use the Booleans more effectively, maybe do some loops and some function calls and all the other good stuff. And hopefully soon we can have you writing your own programs. But that's going to do it for me. Hopefully this video was helpful. If it was, don't forget to subscribe and like and all that other YouTube jazz that YouTubers are always shilling. If this video didn't help you, don't forget to dislike it because that tells me I need to do better, and that tells other people not to watch this tutorial because there's a better one out there. Never be afraid to dislike the videos as long as YouTube allows you to, because that does actually help get the right videos to the top of the algorithm list. So, it's not like it's you saying I'm bad as a software developer. Maybe there was just something off with the video. Maybe I just did something wrong. It's fine. It happens. Don't be afraid to dislike the videos. But that's going to do it for me. Thank you so much for watching. I will see you in the next video, and have a wonderful day.